Hello, and thank you for joining us for ArcelorMittal's webinar with Automotive Manufacturing Solutions. My name is Gareth Price, and I'm the Assistant Editor here at Automotive Manufacturing Solutions. Today I'm joined by Blake Zeidemer, the Director for Automotive Product Applications at ArcelorMittal Global R&D, and by Olivier Morio, who leads the Automotive Steel Solutions Design Department at ArcelorMittal Global R&D Montaterre, dedicated to automotive applications. This webinar will focus on ArcelorMittal's S-in motion lightweight steel solutions, which since initial rollout have been assisting OEMs achieve significant body structure weight reductions in production vehicles. S-in motion is now being extended from existing C-segment sedan and pickup truck solutions to mid-size sedans and SUVs for the first time in a multi-vehicle platform. Blake and Olivier will also take us through new advanced products and solutions for hot stamping, cold stamping, and MartINsite steels. Before we start, I'd like to remind you all that to draft some questions that Blake and Olivier will be pleased to answer in the Q&A session following the presentation. Just type your questions into the box in the lower right-hand side of the screen. Also, if you experience any technical issues during the session, please let us know via that same Q&A box, and our team will try to fix it. We hope you'll find the webinar stimulating and informative, and I'll now hand you over to Blake and Olivier for their presentation.
Thank you, Garrett, and good morning, afternoon, or evening to all of the webinar participants as appropriate. As Garrett indicated, we would like to present to you the latest S-in motion solutions, this time for a mid-size sedan and sport utility vehicle. ArcelorMittal has been engaged in the development of generic lightweighting solutions for vehicles for quite some time now. It started back in 2010 with the introduction of our first internal combustion engine C-segment S-in motion solution. And over the last several years, we have extended these solutions to a wide range of light vehicles, including electric vehicles, plug-in hybrids, light commercial vehicles, pickup trucks, even heavy-duty truck cabs, along with a wide range of suspension and other key components like brakes. This latest solution extends this series to a pair of vehicles intended for North American markets. The challenge in this latest solution is that up to this point, all light vehicle solutions, whether it's been by a steel company or other organization, have really focused on individual vehicles, one-off vehicles. The problem of that is most OEMs don't build individual vehicles. They use multi-vehicle platforms that include many different styles, sizes, and certainly a wide range of powertrain options. Steel solutions for individual vehicles, therefore, invaluable because they really need to comprehend this wide range of weight requirements. The solution in our latest S-in motion has been to develop a catalog solutions for a platform, not just an individual vehicle, but a platform that includes both a mid-size sedan and a mid-size sport. We took on this program with the intent to provide impressive weight reduction in spite of these challenges and keep this to a very affordable cost while meeting or exceeding all pertinent safety and performance requirements. The baseline for the sedan and the sport utility vehicle are shown here. They were taken from vehicles, and we'll talk about the specifics in just a moment. The baseline sedan was 385 kilograms within the scope, which included the body and light bumpers and door and light systems. For this sport utility vehicle, it was 522 kilograms. Our objective in each case was a 20% weight reduction beyond the baseline while maintaining and enhancing all of the various pertinent load pieces for both safety, crash, as well as for NVH, stiffness, and other handling requirements. Like all of the other ArcelorMittal S-in motion solutions, these current ones comprehend two types of material applications. The first looks specifically at ArcelorMittal grades that are currently available in commercial production. This includes the wide range dual phase, complex phase scenarios, press hard steels like Usibor, as well as the MartINsite family, up to 1700. The emerging grades look at all of those which are going to be developed and available within the next a couple of years. This allows us to look at additional weight reduction that can be gained through steels that will become commercial shortly. Now, if we look at some of those emerging commercial grades, certainly the press hardening steels are very important, very rapidly growing right now. There are two key types of press hard steel grades in our portfolio. First, the Ductibor are press hardened steels that after heat treatment, in the same heat treatment one would give the Usibor, the Ductibor family provides a lower strength but much higher ductility. These are intended for energy absorption applications when laser welded to Usibor. On the other hand, and right now we're commercially available with Ductibor 450 and 500, and within, say, the next year or so, Ductibor 1000 doubles. This will provide a additional 10% weight reduction over the grades. Likewise, we're expanding the strength levels of Usibor. Currently, we're producing Usibor 1500, and within the next year or so, we're going to be producing 1000, again providing a 10% weight reduction over that. Likewise, we are introducing the third generation steels for cold standing grades. Our Fortiform grades are intended to provide at least a 10% weight reduction over the grades that they replace. In this case, Fortiform 980 will replace DP 600, Fortiform 1050 will replace DP 780, and Fortiform 1180 will replace DP 980. The mechanical properties of these grades are intended to match the formability in place so that we can maintain manufacturability while we continue to provide additional weight. Now, let's get on to some of the benchmarks. For the sedan, we looked at 5 very popular cars in North America: Fusion, the Accord, the Malibu, Camry, and Altima. And if you look at the sales numbers for those, they represent probably 2/3 of the vehicles that were produced and sold in North America. Over on the right hand of the slide, in the upper corner, you can see the weight of a baseline vehicle, which is right in there with some of the other benchmark vehicles. And if you look in the lower right hand, you see the materials that were used in these things. And again, in this case, the baseline vehicle material content was very, very similar to that of the benchmark vehicles. For the sport utility vehicles, again, we looked at popular SUVs in North America. Again, the weight of baseline is nicely in line with those of the benchmark vehicles. Now, in this case, the benchmark vehicles were a little bit older. They were introduced a little bit earlier in this time frame, and in this case, they actually
we've some audio problems. So, Blake, what we're proposing to do is ask Olivier to step in a little earlier and continue the presentation, and hopefully sound quality problems we can deal with.
Okay, go ahead.
Can you take over?
Yeah.
Okay, Olivier, if you can go ahead.
We were. Yeah. So thank you. Yes, we had some little small issues. So yes, Blake, you was presenting some figures about the benchmark we did at the beginning of the project. So here you have on that page the things we studied on very popular SUV, and we rebuilt in fact a kind of virtual baseline for the SUV solution. And you can see that the S-in Motion baseline considers a very representative advanced high-strength steel portion. which is quite representative of the state-of-the-art vehicles on the market. So we also built S-in Motion mid-size project on a platform basis, like Blake presented at the beginning. So we started from the S-in Motion mid-size sedan vehicle, and we built the SUV body in white from that underbody, and you can see on the bottom picture that we have 25% of underbody mass, which is carried over from the sedan to build the SUV. That means 86 parts are common, and you can also see that on this picture that the common parts are green on the underbody, and we also reworked or redesigned the blue, some blue parts to extend the wheelbase up to 90 millimeter. So we also studied on that project the impact of the bandwidth. That means the different engines that a platform can have on the different vehicles. So the results here are very robust because we added 200 kilogram on the initial version to get a very robust solution, as I said. So here you see adding 200 kilogram additional kilogram on the vehicle, and to cope with all crash requirements and stiffness requirements, we only needed to add 3.5 kilogram at the end for the very severe crash test, the small overlap rigid barrier. We also added very few grams, I would say, to cope with the roof crash or the rear side crash test or the side impacts. So at the end, we have a very robust performance of major load case, crash load cases, only with local reinforcements that represent 3.7 kilogram. So here we will summarize now the results achieved on that project. So first on the SUV. On the SUV, we remember the baseline as first, as Blake presented at the beginning. So I will just look at more in details on the solutions. So here we put on the slide the solution with current grades. That means available steel grades at ArcelorMittal. So here we achieved 20% weight saving on that. On that solution, sorry. That means 102 kilogram weight reduction, which is very, very impressive for this kind of vehicle. So here you can see that we also achieved very light body in white of 360 kilogram. And then the rest is for the front doors and the rear doors. We have also developed, as we said at the beginning, a solution with emerging steel grades. And here you see that you can add additional weight saving up to 112 kilogram weight reduction with Usibor 2000, Ductibor 1000, and the Fortiform family, which represent a very high amount of advanced high-strength steels at the end. And here you can see on the pie chart that we, for emerging grades, we have chosen to push a very aggressive scenario with pressed hardened steel that represent more than 30% of the body-in-white structure. For the S-in motion mid-size sedan, you have here the figures. On that vehicle, we achieved 86 kilogram weight reduction for the full scope, with also a very important use of pressed hardened steels, up to 36% with Usibor 1500 and Ductibor 500 for current grade solution. And we also did the same exercise with emerging grades. And you see here we were able to increase this PHS amount up to 40%, 40% with Usibor 2000, Usibor 1500 for some parts, of course, and Ductibor 1000, our new steel grade for hot stamping, which is very efficient in energy absorption. So we found very new applications for that grade, which are very, very efficient for lightweighting. And you see that we achieved 100 kilogram weight reduction for that solution with emerging grades, leading to a very low body-in-white, as you can see on the table, at 244 kilogram. Sorry. So here I will go more into detail now to highlight the solutions leading to these very light body-in-white structures. The S-in motion mid-size sedan pie chart here shows the applications of ArcelorMittal steel grades. So you see that we applied on the sedan version more 33%, sorry, Usibor 1500 to build a very strong safety cage, as shown on the picture. And MartINsite and dual phase steel grades also account for 20% of very important, or I would say key parts of the body-in-white to also optimize the weight saving. We also applied our new DP490 grade for exposed panels, and I will come back later on. Laser welded blank solutions also contribute to save weight, of course, and optimize crash and stiffness performance. In the sedan version, we used 34 laser welded blanks on different parts. Was 65% in mass are for hot stamping. That's more or less the red parts on that picture. And in fact, these laser welded blank also allow integrating a lot of reinforcements and allow lowering assembly cost in that way. Looking at the front structure, we were able to save 7 kilograms on the scope, despite the fact we had to cope with the small overlap rigid barrier crash. So you can see here we saved weight, but we also meet very good requirement, good achievement in this very severe crash test with a good rating, starting from a baseline with acceptable weighting. So that means the solution is lighter and meets the currently most severe requirement meet the requirements, of the most severe crash test currently on the automotive engineering. For that purpose, we developed a new front and body side structure, which was fully redesigned from the baseline to meet all frontal and side impact requirements, but especially the very body structure compliant with the small overlap crash test. And here you can see on the animations that the body in white on the right has a very good behavior with a very strong life cell at the end of the crash test. So to get this very good result, we played on several parts, like explained on that slide. So first we extended the bumper beam, the MartINsite bumper beam in 1700 to engage the front rail as much as possible. Front rails and shotgun are optimized with laser welded blank in dual phase 590, 780 and 980 to absorb more energy. Usibor 1500 based firewall reinforcements minimize intrusions. And finally, an optimized single-piece laser welded blank door ring made by 1500 and Ductibor 500 reinforce the strong body side structure. Let me highlight a very interesting part, the shotgun. For that part, we optimized the laser welded blank of both parts, making that structure with dual phase 590, dual phase 780 and 980, leading to the best compromise to cope with all frontal crash tests as described on the slide. First, keeping a very good deceleration at 28 G for the full frontal USM cap crash test, as described on the left-hand side, and offering a very high energy absorption for the small overlap crash test, as described on the right-hand side. And you can see on the animation that this structure is able to absorb a lot of energy and then to transfer also to stop the deformation and transfer the load to the safety cage. Going to the body side structure, 26 kilogram per vehicle can be said on the body side structure. Thanks to extensive use of pressed hardened steels and laser welded blank solutions. First, on inner panels, as you can see, this is very important to reinforce these parts, especially for the roof crush, for example. And then for the reinforcement, one-piece laser welded blank door ring has been optimized with ArcelorMittal Tailor blank. With 6 sub-blanks in Usibor 1500 and Ductibor 500, providing high anti-intrusion performance. For the floor structure, 40% weight saving can be achieved thanks to the intensive use of Usibor 1500 and hot stamp laser welded blank again. Like on the front rail extension in the bottom, which has a free portion of Usibor 1500 and is a key part for anti-intrusion in the body in white. Like on side seals, inner side seal also, but also very important applications on the tunnel reinforcement. This slide highlights also an interesting application for hot stamped laser welded blank it's on the seat cross member. So you can see that Usibor 1500, that Ductibor 500, on these parts are very efficient solution for side pole crash tests. Offering an absorption area on the side end of the parts, and a very resistant portion going to the center of the vehicle, as described on the animations and deformation views for the 5th percentile and 50th percentile pole test. So you see, on for example, on the right-hand side, and the fuse, in fact, area at the end, at the side end of these parts, that helps a lot to absorb energy, and then you have a very strong behavior of the rest of the structure, including the tunnel reinforcement. Let's move to the closures, and for example, the front door of the S-in motion mid-size sedan vehicle. So in that case, we achieved 15% mass savings thanks to inner and outer panel down gauging, supported by appropriate structural design change, like Usibor 1500 application on door beam and hinge reinforcement in red on the picture, but also with new laser welded blunt application on the door inner panel. We also applied our new grade for exposed panels, the dual phase 490. This grade has a very high dent resistance behavior and allows to down gauge this panel, in that case, to 0.58 millimeter, compared to a baseline in bake hardening grade, in bake hardening 210 in 0.75 millimeter, allowing 33% weight saving. The part can be stamped very easily without any issues. We checked by simulation, but we also did some prototype trials in our press shop till 0.5 millimeter thick, and even in this very thin gauge, we didn't. We had very good parts with a good surface quality and without any rupture. Surface finish around door handle and panel stiffness were also assessed and meet the requirements as shown on the figures on the bottom of the slide. For the stiffness, for example, we checked that at different points, like mentioned on the picture of the door structure, and we get a very good behavior thanks to the position of the different door beams, the main door beam, but also structural reinforcement inside the panel. All these results show you that ArcelorMittal R&D can support its customer to down gauge outer panels. ArcelorMittal Dual Phase 490 is a full finished product specifically developed for outer skin panels. The high yield strengths, as described in the table on the right, provides very good dent resistance performance. As you can see also in the table, the elongation, the very high elongation, provides good forming properties as well. The product is available in GI in Europe and both GI and GA in North America. Development in GI is ongoing in South America and could be done also in China, depending on the market request. The feasibility is open down to 0.6, but as I already mentioned, we also processed some coils down to 0.5 with very good exposed quality. Now I propose to give you some words and figures on performance of the S-in motion mid-size sedan vehicle. First, the crash performance assessment. So here you have the table of all load cases that we checked during the project. I will not comment all the figures, but you can see we had set targets for all crash load cases, and you can find also the achievements for the baseline and the solution as well. And you can see that we all the criteria meet the requirements, and for some of them we are above the target. Static and dynamic stiffness were also optimized, as described in this table. The solution meets all global stiffness targets and matches baseline performance. Thanks to first topology optimization, gauge optimization, and adhesive application. We only apply 60-meter adhesives to cope with the stiffness loss after crash behavior, or crash optimization, I would say. Okay. So I think we are. It's time to go to the conclusion, and but also to the cost estimation. So like we do in each S-in motion project, we performed a detailed cost analysis with an external company which is working with us for every S-in motion project. So here you can see the figures of the solution, S-in motion mid-size sedan, compared to the baseline. So we are only 7% higher in cost. That means all the solutions are only about $1 per kilogram saved higher on cost, which is quite interesting. Of course, the figures are very different from part to part, but globally speaking, these very aggressive applications of PHS and advanced high strengths on the body-in-white structure is very affordable. So on the slide, you have also the hypothesis taken in this cost analysis. Amortization is over 5 years, and we did the cost estimation on the production of 300,000 vehicles per year. So, and you see we divide also the cost in material cost, process cost, and assembly, and tooling amortization. So, in conclusion, we can say that ArcelorMittal solutions have reduced the weight of the baseline by 86 kilograms, or 23% for the sedan version, and more than 100 kilograms for the SUV, with steel grades already commercially available. And the most interesting fact is that we also offer additional weight saving of 14 kilograms or 10 kilograms for the SUV for when we take into account our emerging grades, especially when we will apply Usibor 2000 and Ductibor 1000 and Fortiform grades, which will be commercially available within less than 2 years. So it's very promising for achieving very interesting weight savings on body-in-white engineering. Weight savings were achieved for large bandwidth, as presented in the beginning, and for multi-vehicle platforms, which is also very robust in terms of solutions. These solutions can be implemented with only a small cost increase. And of course, as already said in S-in motion project, this S-in motion mid-size sedan and SUV solution can be adapted to OEM specific design and requirements through co-engineering project. You know that ArcelorMittal is not a car maker, but we are ready to share all these results and adapt these results to specific requirements or specific architecture. And of course, the solutions presented today are not the solutions, but are ready to be shared with our customers to make lighter cars for the future. Thank you very much for your thank you very much for your attention. And again, sorry for this small perturbation in audio during the webinar, but I'm sure that you will have a very interesting question. I'm ready to listen to these questions, and Blake too.
Thank you, Olivier. I think because of the audio problems, I'm not sure Blake will be able to participate in the Q&A. Yeah,
okay.
If you could field the questions we do have. And by all means, if the people listening, if by all means send in questions through the Q&A box on the lower right-hand side of the screen. But kicking off, Olivier,
yeah.
First question, when will the new PHS grades, Usibor 2000 and Ductibor 1000, or the third generation cold forming steel grades, when will they be available?
Yes, as we said, we are in the last phase of development for this new grades. So for the PHS grades, for Usibor 2000 and Ductibor 1000, test material is already available. We are in the phase, in the step where we are producing a lot of industrial trials. And so test material is already for the customers, and we already sent a lot of to different car makers. But we will wait for the feedback in the qualification procedure to plan the commercialization of the product. But it should be beginning next year. And for the Fortiform, I think it's much more complicated because we have several versions. You have Fortiform grades in cold rolled, but also in with coated version. So we are also in the phase of industrial trials for these for the 980 and 1180. And the Fortiform 1050 is already commercial in cold rolled version and EG version. And for 980 and 1180, as I said, we are in phase of industrial trial, and test material will be available next year, probably in the mid of next year.
Okay, thank you, Olivier. Also, next is a question on crash management.
Yeah.
Our listener wants to know: did you compare LWB and multi-wall crush tips in terms of cost and in terms of weight?
Could you? I understood multi-wall.
Multi-wall crash tips.
Multi-wall crash tips. Sorry, but I don't. For which part do you have? For the crash management system, I guess, because crash tips are.
Yeah, for crash management.
Yeah, we in fact we optimized the crash management system because we think that it's a very important system for the most TV or crash load case, as I presented the small overlap rigid barrier test. and crash cans, if it's this part we are speaking of, was also optimized. But we worked a lot on that part, and we know that yeah, you need to keep a soft material. So DP780 is a very good candidate. You can go even higher in strength, but you also need deformation on that part. So, but I don't see the technology that proposed in the question, because I don't know which is the technology called multi-wall. Sorry.
Okay, thanks, Olivier. Next question. How do you see the implications of these steels on heat treatment and galvanizing process?
Could you repeat, please, the name of the steel? Because there is a lot of
on any of the steels.
Background, sorry.
On each and every of the steels that's under discussion.
Yeah.
Applications around heat treatment and galvanizing processes.
For the hot stamping steels?
I believe so. If the listener can expand, if there's a specific type of steel that they're inquiring about, or any of the steels involved in.
Yeah. In fact, if we are speaking about the steels for hot stampings, Usibor 1500 or the Ductibor 500, they are aluminum silicon coated, and we also have in our portfolio galvanized version, but the main product that we provide is the aluminum silicon coated. It's not a galvanized product.
Okay.
Because the aluminum silicon coating is the best suitable for hot stamping technology.
Okay, thanks. If someone wanted to check if these lightweighting solutions would work for the design of future car models, what would be the next step for them to take?
The next steps to make it still lighter, or the next steps to apply it?
Yeah, how to apply it on
yeah. Okay.
design of their future models. What sort of steps can they take?
Yeah, I think it's a very good question, because you know, as I said at the end, here we just highlight the potential of new current or new steel grades, and we know that there are a lot of different architectures. We also know that we took major crash load cases, but that car makers have also internal additional load cases. So our goals making this S-in-motion project is also to trigger co-engineering activities, co-engineering project, or for future models, car models. And I think it's a key. It's key to share these first results, to show to our customer that we have some ideas to apply these numerous advanced high-strength steels, and as we said at ArcelorMittal, to put the right steel at the right place, with the right gauge and with the right geometry. And that's really the best answer I would have to that question. So the application of this solution is really specific to each customer, and it goes through co-engineering projects.
Okay, thank you, Olivier. And next question we have, implementing more hot forming steel grades and increasing the complexity of the body in white structure. How do you avoid a significant raise in costs?
No, I think we can be convinced by the cost estimation we did and that I presented at the end. The only message I would have is not to look at single part by single part. You really need to look at a module level at least, or a full body in white level. And even with 35% pressed hardened steel in the body in white, you can really limit the overcost as I presented. We achieved with only 7% higher in cost. That means less than $1 per kilogram saved. So it gives a first estimation of the impact of so many parts in hot stamping. But we are really convinced that it's not a roadblock because you have no stampers that make a very innovative process, making several parts in one stroke, maybe making parts, optimizing the nesting also, making very limiting the, for example, the laser cutting after the hot stamping step. So I think it's evolving very fast, and we see that it's not so. It's very affordable.
Okay, thank you. Just a couple of performance questions here now. Firstly, could you tell us the yield strength for Ductibor 2000, and also the percentage elongation for Usibor 1500 and Usibor 2000?
It's a good point. Thanks for the question. So you know that Usibor 2000 was developed to have a very efficient weight reduction at the end compared to Usibor 1500. So our target, yield strength target, is 1400. So we developed that grade to have a yield strength higher than 1400. Really, because these parts or these applications are really yield strength driven, because it's mainly on anti-intrusion parts. So we had to increase the stiffness of Usibor 1500. That's the first point. And then it was on elongation. So I would start first by take care with elongation after hot stamping. It doesn't mean nothing. Because as you can see on maybe I will come back on the slide of Usibor of PHS grades for the participants. Sorry. Yes, this one. So you see here we present the properties of these grades in, of course, UTS on the x-axis, but in crash ductility on the y-axis, because residual elongation on PHS grades doesn't mean nothing. Here you have to deal with the crash ductility. That means the ability of the part to develop locally when the part is bending, for example. And this ability is really related to the bending angle that we can, by a simple test, measure after each industrial test in our pressure, in our mill when we do industrial tests. So here again, I would alert again, and we do it very often. For press hardened steel, you need only to think to crash ductility. So here the crash ductility of Usibor 1500 is related to the mesh size when you do crash simulations. So it's not only one value, so it's very complicated. But we provide the material cards for all the steel grades, and there is a communication kit available for all our teams to explain these figures.
Okay, thank you, Olivier. There are still lots of questions. I'll probably only have time to keep it on. But rest assured, all the questions will be forwarded to both of our presenters. So none of the questions will be overlooked, and we'll be able to get back to you. But just one final one for you, Olivier. It's regarding corrosion concerns. Are there corrosion concerns with the new materials?
No, because the corrosion will be handled through the coating, and so here for the new materials, Usibor 2000 and Ductibor 1000 will be proposed in aluminum silicone coating, like Usibor 1500, and also these materials were developed to be used with the same hot stamping process. So that means you will be able to combine Usibor 2000, Ductibor 1000 with Usibor 1500, for example, through the laser welded blank technology. So the corrosion behavior of these new PHS grades will be as the one of the already known PHS grade commercialized by ArcelorMittal. And for the Fortiform family, as I said, we have several development in progress. So the products will be available in cold rolled version, of course, but in GI and GA, of course. And also we developed the new coating process called JetGal by physical vapor deposition. So you see that the coatings will be there to protect these new steel grades from corrosion.
Okay, thank you, Olivier. Perhaps just got time to squeeze one final one in, so see if you can shed light on this one. The listener's asking, when evaluating the overall performance of as vehicle level crashworthiness and stiffness, did you evaluate local stiffness? For example, local panel stiffness as roof panels of door panels?
Yeah, it's a very good question. Yes, of course, we didn't have time to show everything. Indeed, I presented only a table on global stiffness, and of course we had a set of local stiffness requirements for the body in white first, and then for the door optimization we had several stiffness load cases, model analysis, of course, for each submodel. Like done, I would say, classically in automotive engineering.
All right, Olivier. Actually, can we squeeze yet one more in? Well, the question they are coming in. We will get all of them over to you, as the listeners know. But we want to take advantage of you whilst you're here. The question is asking, has ArcelorMittal considered having a hot forming grade in between 1500 MPa and 1000 MPa tensile strength? For example, 1300 MPa. Could such a grade bring further weight reduction?
Some years ago, we thought to different levels of mechanical properties, but I think we decided to, as Usibor 1500 is already a lot applied in different vehicles, we really wanted to focus on a new grade with very high strengths, but also a lot of crash ductility, as I mentioned before, because we think that's also a very interesting grade to make weight saving compared to our previous Ductibor 500, for example, but also compared to dual phase grades that could be applied in different parts. So my answer would be no. We don't plan to develop a new grade in between, because we think that the future is more on Ductibor 1000 for soft area where you need the energy absorption. And we will have Usibor 2000, which is really the future, because we identified that most of the part in Usibor 1500 can be applied in Usibor 2000.
Okay, thank you so much, Olivier. And thanks to everyone listening for joining us today. Thanks again to Blake. Apologies to everyone listening for the technical glitches which affected the audio quality that we experienced at the beginning of the webinar. But of course, the webinar will be uploaded into the AMS archives and accessible for any colleagues who were unable to join us for the live presentation. And you can access this and all of our previous AMS webinars via the webinar tab at the AMS homepage. We'd like to get your feedback on the webinar, and so there's a short survey coming up. Please take the time to complete this, as we very much appreciate your input. And thanks again for taking part with us today. Thanks to Blake and Olivier, and we'll hope you join us again for the next webinar. Bye for now.